Hello everyone. In this page, we are going to learn about the electric motor. An electric motor is a device that converts electrical energy into mechanical energy. In simple words, an electric motor uses electricity to produce motion. An electric motor works on the principle that when a current-carrying conductor is placed in a magnetic field, it experiences a force and tends to move. Now let us understand its construction and working. Here, we have a rectangular coil ABCD placed between the two poles of a magnet. The left side is the North Pole, represented by N, and the right side is the South Pole, represented by S. The magnetic field lines move from the North Pole towards the South Pole. The coil is connected to a split ring commutator. Two brushes are placed in contact with the split ring, and the brushes are connected to a battery. When the switch is closed, electric current starts flowing through the coil. Because the coil is placed in a magnetic field, the two sides of the coil, AB and CD, experience forces in opposite directions. These opposite forces produce a turning effect called torque. As a result, the coil starts rotating. But how does the coil continue rotating in the same direction? This is where the split ring commutator plays an important role. After every half rotation, the split ring commutator reverses the direction of current through the coil. Because of this, the forces continue to act in such a way that the coil keeps rotating in the same direction. So, the energy conversion in an electric motor can be remembered as electrical energy right pointing arrow current in coil right pointing arrow force in magnetic field right pointing arrow mechanical energy or rotation. Electric motors are widely used in our daily lives. They are found in fans, coolers, mixers, washing machines, water pumps, and many other electrical appliances. So remember the main point: an electric motor converts electrical energy into mechanical energy. Now let us move to the second page, which explains the electric generator. An electric generator is a device that converts mechanical energy into electrical energy. In simple words, a generator uses mechanical motion to produce electricity. An electric generator works on the principle of electromagnetic induction. According to this principle, when a conductor or coil moves through a magnetic field and cuts magnetic field lines, an EMF, or electromotive force, is induced in the coil. Let us understand the working shown in the diagram. Here, a rectangular coil ABCD is placed between the north and south poles of a magnet. The coil is connected to a split ring commutator, and two brushes are connected to the external circuit. When the coil is rotated mechanically in the magnetic field, the sides AB and CD cut the magnetic field lines. Due to this motion, an EMF is induced in the coil. If the external circuit is connected, current flows through the circuit. The split ring commutator reverses the connection after every half rotation. Because of this, the current in the external circuit flows in the same direction during successive half rotations. Therefore, mechanical rotation is converted into electrical energy. The energy conversion can be remembered as mechanical energy right pointing arrow rotation of coil in magnetic field right pointing arrow induced EMF right pointing arrow electrical energy. Electric generators have many important applications. They are used in power plants, wind turbines, hydroelectric plants, and other systems where mechanical energy is converted into electrical energy. So remember the main point: an electric generator converts mechanical energy into electrical energy by electromagnetic induction. Now let us learn about the magnetic field due to a current-carrying conductor. When electric current flows through a conductor, it produces a magnetic field around the conductor. The magnetic field around a straight current-carrying conductor consists of concentric circular magnetic field lines. But how do we find the direction of these magnetic field lines? For this, we use the right-hand thumb rule. Let us understand this rule carefully. Hold the straight current-carrying conductor in your right hand. Point your thumb in the direction of the current. Now, the direction in which your curled fingers wrap around the conductor gives the direction of the magnetic field lines. So, remember it in 3 simple steps. Current direction right pointing arrow thumb points in the direction of current right pointing arrow curled fingers show the magnetic field direction. For example, in the diagram, the current is flowing upward through the conductor. Therefore, if we point the thumb of our right hand upward, the curled fingers show the direction of the circular magnetic field around the conductor. This rule helps us understand how a magnetic field is formed around a current-carrying wire and how its direction can be determined. So the important point to remember is, a current-carrying conductor produces a magnetic field around it, and the right-hand thumb rule gives the direction of that magnetic field. That completes our 3 concepts: electric motor, electrical energy is converted into mechanical energy. Electric generator, mechanical energy is converted into electrical energy. Current-carrying conductor, Electric current produces a magnetic field around the conductor. These concepts are very important for understanding the relationship between electricity and magnetism.